Hello everyone, myself Bhavesh Tavre. I am first year MTech student in Computer Science department at IIT Patna. Me with my other four teammates, namely Vikram Kumar, Ravi Kumar, and Himanshu Kumar, are presenting our project presenting our project with the title name Academic Timetable Generation System for the coursework of Advanced Artificial Intelligence under the supervision of a Dr. Arjit Monda sir. This is the integrated approach using the concept satisfaction problem, heuristic techniques, and meta-heuristic optimization for conflict-free and efficient academic scheduling. Okay, so timetable generation is a complex task, especially in a large institute like IIT Patna, where the multiple courses, faculty schedules, and the classroom content must be managed without conflicts. So the traditional manual methods are very slow and often leads to error. So our project aims to automate this process using the concept satisfaction problem, heuristic and meta-heuristic algorithm. The goal is to create the optimized conflict-free schedule that improves the resource usage and reduces the effort for both students and faculty. Okay, so let's discuss about what are the problem statement we are solving and what are the challenges we have to solve. So we have the student data and each student is having a multiple courses with the different components in the course like the lecture, tutorials and practicals. Our task is to schedule on a particular given day. We have to schedule a time slot and a room for every subject component with handling the different types of conflicts such that the students with the overlapping classes like the one student should not have the class two different class in two different rooms for two different subjects like that at the same time. Then the faculty teaching multiple courses like the one faculty should teach at a time at one for one subject in a specific room. It should not be happen that the one faculty having the multiple courses teach at the same time to the different students. Then the room overbooking or the capacity mismatch like if we have 100 students and the capacity only 50, this should not happen. While handling the various formats like the lecture can be have three lectures which we can schedule on three different days like one, or we can do like we'll assign one lecture on one day and the two different lecture on second day. And the practical should happen in a consecutive time slot only like if the practical is of 3 hours then it should happen in the same consecutive time slots. And we have to operate our schedules classes in between the 8 a.m. to 6 p.m. and excluding the 1 p.m. 2 p.m. for the lunch break. Okay, so what is our aim to achieve? So our main aim is to generate the complete valid timetable without any conflicts. Once we get that timetable, then we can do the optimization in it. Like we have to minimize the gaps between the classes for students and faculty, avoid the early morning so that the early morning rush should be avoided, and the late evening so that the tiredness of the student or the faculty should be avoided, and the minimization of room switching for the consecutive lecture for both teacher and students. So all the optimization we can achieve using the heuristic and meta-heuristic algorithms on top of the CSP constraint that we are performing, and we have to make sure that our solution should be scalable and adaptable so that any future scope for this project can be implemented like the dynamic time scheduling. So let's discuss about the input data or the CSV file that we are taking for this project. So we have the four CSV files. The first one is the student registration data, in which we have the student data like their roll number, amount of student we have, total number of student we have, then the number of subjects they have taken as a subject 1, subject 2, subject 3. Then second file is the subject details, in which we have the different subject, their subject code, then the number of lectures we have, tutorials and practical if applicable. Then third file includes the faculty assignment details, which nothing but an employee ID of the faculties. Then the subjects, we are assigning only max two subjects per faculty. Then the which subject they are teaching that data. And lastly, we have the room detail file submit, in which we have the room number and the capacity of the room included. Okay, so let's discuss about the overall algorithms that we are using in this project. So in this project, we explore the three different algorithms approaches for genetic academic timetables, constraint satisfaction problem, then the heuristic method and the meta-heuristic techniques using the genetic algorithms. The CSP approach focuses on the satisfying the hard constraint like avoiding the class caches, room conflicts, and faculty overlaps. It uses a backtracking algorithm along with the domain reduction to find a feasible solution. While the highly accurate being the very highly accurate, the CSP tends to computationally expensive, especially with the large data set, sometimes goes in the exponential time complexity. So to avoid this, we have the heuristics method, On the other hand, in which is a fast rule based and it schedules the session by greedily selecting the available time slots, room and faculty. While it does not guarantee an optimal solution, it's highly scalable and quickly generates the decent timetable, making it suitable when the education is our priority. Finally, we implement the metahueristic generator algorithm, which mimics the natural evolution. It starts with the randomly generated timetable candidate and iteratively improves using the crossover, mutation, and fitness evaluation, which we will discuss in the later part. The fitness function minimizes the lecture gaps and room switches for the student, making it optimized. And this approach balances the speed and quality, producing the well-optimized timetable while handling the soft constraint effectively. Now, my other teammate will continue from here.
Hi, myself Kumar Imansu Shekhar, and I will discuss the CSP approach of academic timetable generation problem. So let us begin with the overall approach of solving the academic timetable problem, where the goal is to assign timetable slot and room to each subject such that all the sessions are scheduled without any conflict. In the CSP model, each lecture, tutorial, or a practical session is treated as variable. The domain for each variable is a set of valid combination of day, time slot, room, and faculty filtered by constraints like room capacity and faculty availability. Now we will discuss few of the constraints used to solve the CSP problem. So no two sessions should occur in the same room at the same time. A faculty member must not teach two classes at the same time, and a student should not have overlapping classes. We also handle a special condition like practical being placed in a single continuous block and lecture preferences such as avoiding 8 a.m. slot. Now the core algorithm used to solve the CSP problem is recursive backtracking. This means we try assigning a valid time slot, room and faculty to each session one by one, and if we hit a conflict, we backtrack and try alternative option. The algorithm check for all type of conflict like room, faculty, student at each step. If we can't find a valid assignment for a session, we undo the previous assignment and explore the other option. The process continues until either all the sessions are scheduled or we determine that no feasible schedule exists. Now, let us look the CSP implementation in more detail through this pseudocode. We first start by loading all required data. This includes student registration, subject detail, faculty assignment, and room information from CSV file. Then we process the data, break down each subject into session like lecture and practical, map subject to enroll a student, and match faculty to subject. Next, we define variable. Each session is a variable with its associate detail like enrolled student and eligible faculty. After that, we create a domain for each session. This includes all possible combination, day, slot, room, and faculty that respect capacity and availability of constraint. The backtracking function is where the actual search happens. It selects the variable with minimum remaining value, which helps reducing branching. Then for each possible combination in its domain, it checks is the room free, is the faculty available, are all students free. If the combination is valid, we assign and move to the next variable. If no valid option remain, we backtrack and try next choice. Finally, we find complete valid schedule. We export it to a CSV file. Otherwise, we print error message stating that no feasible solution was found. So this detailed pseudocode ensures system maintain correctness while exploring all the solutions in systematic and constraint-aware manner. This is the table generated by CSP approach. While the CSP approach is powerful and guarantees correctness, it does have some limitation. Now we will discuss these limitations. So it can become computationally expensive, especially with large dataset involving hundreds of students and courses. It also focuses mostly on hard constraints, so if you want to consider student comfort like minimizing idle gap, CSP alone is not enough. Additionally, CSP is not great at adapting to real-time changes like last-minute course addition, room availability issue. That is why in our overall approach, We complemented CSP with heuristic, meta-heuristic algorithm like genetic algorithm, which will be discussed by other member of my group.
Now let's discuss about how meta-heuristics such as genetic algorithm helps overcome complex optimization problem in scheduling and similar domain. First, we have scalability. Meta-heuristics are specifically designed to efficiently explore large and complex search space. Algorithms like genetic algorithm, selective annealing, या Tabula search don't just perform exhaustive search, they are use intelligent strategy to reach near optimal solution, even when the search space is massive. Second is flexibility. One of the major advantages of these approaches is their ability to handle both hard constraints like room and faculty conflict, and soft preference such as avoiding early 8 a.m. slots and minimizing ideal times for students. This makes them highly adaptable and real-world scenario where rules and preferences vary. Third, meta-heuristic are optimization-oriented. Unlike traditional constant satisfaction approach that are merely try to find feasible solution, but meta-heuristic aim to optimize the overall quality of the solution. For instance, they can reduce students' gap between classes, या minimize the number of room switching. And finally, adaptability. Meta-heuristic can dynamically adjust to new input या constraint. This feature is extremely useful in real-life scheduling where last-minute changes are quite common, like a faculty member becoming unavailable या classroom being reassigned. So overall, meta-heuristic technique provide a powerful, flexible, and robust way to handle complex scheduling problem. B uses genetic algorithm for timetable scheduling because they are quickly find the good solution even when there are many rules and options. They avoid classes, improve the timetable steps by step, and can easily adjust if something changes. That's why among the meta-heuristic algorithm, genetic algorithm will be the best. Now discuss about what are the steps in genetic algorithm. Let's break down how the genetic algorithm work in this context. First, we begin with an initial population, a set of randomly generated timetable. Each timetable is then evaluated using a fitness function. This function checks things like how ideal gaps exist for a student, how many times they have to switch room unnecessarily. Based on this fitness score, we apply selection, where the better performing timetable are chosen to continue. Then come across crossover where we combine parts of two parents timetable to create new offspring. To maintain diversity and avoid getting stuck at local optima, we apply mutation, which introduce a small random change. This whole process continues for a fixed number of generations until we reach satisfactory fitness score. That's our termination condition. Now let's look at the specific goal of our timetable generation. The core objective is to minimize total schedule conflict. Some of the common conflict include first two classes being scheduled for the same student or faculty member at the same time. Second, lab not being scheduled consecutively, which disrupt continuity. Third, lecture being unevenly distributed. For instance, bunching all sessions into one day and leaving other empty. Additionally, we have considered room capacity violation, where the number of enrolled students exceed what the room can accommodate. Addressing all these ensure we don't just generate a timetable but also make a practical and balanced one. Let's now go deeper into the main building block of the genetic algorithm. First is selection. We use strategies like roulette wheel, where timetable with the highest fitness have a better chance for being selected as a parent. This ensures good solutions are more likely to pass on their genes. Next is crossover. Crossover means combining two parents to form a new children. This helps preserve useful building blocks while introducing new arrangement. For example, one parent may have well-structured Monday session while another has better room assignment. So child can inherit both the strength. Finally, mutation introduces random change. This helps to escape local minimum. Let's now talk through the core logic of our genetic algorithm used for timetable generation. We begin with our 4 input file, that is student.csv, subject.csv, faculty.csv, and the room.csv. These files contain the essential information. Next comes the initialization phase. We define constraints like weekday, Monday to Friday, and the time slot between 8 a.m. to 6 p.m. Before we generate solution, we pre-process the data. For each subject, we extract their enrolled subject. And for each subject, we list the faculty who can teach it, and we store room details like capacity and IDs. Then, with the help of generate candidate, this is responsible for creating a single timetable solution. For every session, we randomly choose a day and time block while trying to avoid early morning lunch and late evening. The final product is a full timetable proposal. Now, to evaluate how good timetable is, now we calculate the fitness function of each timetable. For every student, we build their personal schedule. We count how many ideal gaps they have between their first and last class in a day. We also count how many times they change room between sessions. The lower this number are the better timetable. So for this, we are calculating the fitness. Next, we are using crossover where we are generating the child timetable with combining the parent. Then come mutation where we generate new timetable randomly, otherwise the timetable stay unchanged. This prevent population from getting stuck in local minimum. Finally, we have the main loop our genetic algorithm. We start with a population of 30 random timetable for 100 generation, evaluate each fitness function and select the top 50% as a parent. Create children using crossover mutation and replace population with a new generation. At the end, all the generation. This is our output of the code using genetic algorithm. We have the some limitation using genetic algorithm because you may not always find the optimal timetable and may get in the local optimum. They struggle to handle complex constraint efficiently. Also, they can time consuming for large data set. Now the remaining part of the PPT will be discussed by Ravi Kumar.
Hello everyone, myself Ravi Kumar and I am going to explain heuristic idea for timetable generation. So let's start. To address the limitation of genetic algorithm in timetable generation, heuristic repair methods and local search techniques are introduced. These methods allow the algorithm to further improve solution after crossover or mutation, ensuring feasibility and better adherence to constraints. Let's go to heuristic approach. Heuristic in timetable generation use problem-specific knowledge to guide the scheduling process. This includes repairing conflicts that arise during initial scheduling, satisfying hard constraints such as room and faculty availability, and optimizing soft constraints like avoiding early morning slots. By incorporating these strategies, the timetable can be refined to meet both hard and soft requirements more effectively. Heuristic methods provide a practical way to quickly generate feasible and high quality schedules, especially when traditional or meta heuristic approaches struggle with scalability or constraint satisfaction. Key aspects of the heuristic scheduling code is: in first step, we use data loading. The system loads all necessary data for students, subjects, faculty, and rooms from CSV files. In second step, scheduling parameters defines days of the week and available time slots while excluding lunch breaks and other unavailable spots. In third steps, faculty subject mapping ensures faculty are assigned to subjects without double booking. And in fourth step, room availability tracks room uses to avoid conflicts. In fifth step, timetable initialization set up an empty timetable and tracks both room and faculty utilization. And in last step, scheduling process. In scheduling process, we first do slot finding, second room and faculty assignment, third scheduling strategy, and final exporting results. So this approach is a greedy heuristic algorithm. For each subject, the system tries to find available time slots that do not overlap with lunch breaks or other unavailable periods. It ensures rooms and faculty are not double booked. If no feasible schedule is found through normal means, it uses forced scheduling to assign the earliest available room and faculty. Greedy decision.
The algorithm makes scheduling decisions based on local constraints without considering the entire timetable ahead of time. And third one is room and faculty utilizing tracking. Uses data structure to ensure no over allocation within a given day or time slot. Let's discuss about pseudocode. First function is function generate timetable. Initialize timetable with empty slots. Initialize room and faculty utilization maps. For each subject in subject data, get subject code and session details. Create session list based on subjects lectures, tutorials and practicals. Find available room for slots. If room is available, try to assign faculty using faculty subject mapping. If faculty is available, schedule the session in the timetable. Mark the room and faculty as utilized, move to next subject. Else, if normal scheduling fails, apply force scheduling by assigning the first available room and faculty schedule the session. Next function is find next available slot. In this, for each day in days of a week, for each time slot, check if slots are free and valid, return valid. And another function is function find available room for slots. So in this, for each room, check room availability and return available room. And last function is finding faculty for subjects. For each faculty in faculty subject mapping, check if faculty is available at the required slots, return faculty. That's it. So you can see output and its advantage. The heuristic timetable scheduling approach efficiently handles constraints such as room and faculty availability, providing quick solution. It is simple to implement and flexible, allowing for easy adaptation to different requirements. By narrowing down the search space, the algorithm reduces computational cost and is scalable for large data set. The output is a feasible timetable typically exported as a CSV file that balance speed and practically. So let's compare all three algorithms. So first we talk about solution quality. Then in CSV approach, high ensures exact constraint satisfaction. In meta heuristic, high quality solution near optimal. In heuristic approach, suboptimal quick solution. And if you talk about constraint handling, then in CSV approach, strong enforces all constraint. In meta heuristic, moderate, some relaxation allowed. And in heuristic approach, moderate works with available constraint. And if we talk about complexity, then in CSP approach, high evaluates all possible assignments. In meta heuristic, moderate to high depends on algorithm parameters, low quick to implement in heuristic approach. And talk about execution time, then in CSP approach, very slow, especially for large problems. And in meta heuristic, it's moderate, depend on iteration and population size. And in heuristic approach, it is fast, suitable for quick solutions. And talk about scalability, then it is poor for large problem in CSP approach. Moderate performance may degrade with large data set in meta heuristic, and in heuristic best for small to medium sized problems. Let's talk about implementation difficulty. So in CSP approach, high requires detailed constraint definition. In meta heuristic, moderate requires understanding genetic algorithm. In heuristic approach, low, simple and easy to implement. And final part about this is adaptability to changes. So in CSP approaches, it is low, re-evaluation required for changes. In meta heuristic, high, adapts over generations. And in heuristic approach, moderate adjustment and less flexible. Thank you.